The title of lesson 2 is Square Roots and Cube Roots. Make sure that your notebook has that title, Square Roots and Cube Roots. If you ever need to pause the video, make sure that you pause it so you can copy everything down. We will start by covering a perfect square. A perfect square is a number that is the result from multiplying an integer by itself. The number of perfect squares is infinite, but we are only going to be working with the first 15. Now, I'm going to start with the first one, and I want you to write this down. So 1 square is 1. 2 square is 2 times 2, which is 4. And this should come very natural to you just because you know your multiplication tables. Now, numbers 13, 14, and 15 will be more challenging. Pause the video and make sure that you fill the whole table, including 13, 14, and 15. If you don't know, you just need to do long multiplication. Now double check your answers. Perfect cubes are similar to perfect squares. A perfect cube is a number that results from multiplying an integer 3 times by itself. I'm not going to have you memorize all the numbers 1 through 15, but you do need to know 1 through 5. So 1 times 1 times 1, okay, that's what 1 cube means. So 1 times 1 times 1, that will give you 1. And now you have 2 times 2 times 2, and that will give you 8. 3 times 3 times 3 will give you 27. 4 times 4 times 4 will give you 64. And 5 times 5 times 5 will give you 125. So 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, and 5 cube is 125. Now, for roots, we're going to start by labeling every single part. Okay, so we're going to start by labeling our symbol, in this case what we call the radical sign. On the left side, we have the 2, and the 2, even though it's an integer, actually represents the degree. The 5 that is inside the radical, it's called the radicand. Make sure you copy this and label every single part. In math, we have inverse operations. So for addition, we have subtraction. For multiplication, we have division. So when we are squaring a number, the inverse operation of squaring a number is the square root of a number. A square root of a number is any number that you can multiply by itself to get your original number. For this class, we are only going to be dealing with positive square roots. There are negative square roots, but we are only going to be working with positive square roots. That means that the radicand will be positive. In page 12, you're given a square with length s and height s. So base or height both equal to s. Now they're telling you that the area inside the square is actually 49. We know that the formula for the area is side square or length times width. In this case, we know that we have s times s, which is equivalent to s to the second power. And we know that s to the second power is actually equal to 49. Okay, now we are going to be looking for the value of s. What we need to do in this case is isolate the variable. So we're trying to leave the variable by itself. Now, to do that, we need to use inverse operations. So I am going to use the square root since it is the inverse operation of squaring. So I'm going to write the square root on both sides. Okay, and now I have the square root of s to the second power. That cancels out, and you're left only with s, which is going to be equal to, we're going to add a plus or minus, because technically I will cover why you need to do this plus or minus later on. So we are going to write plus or minus the square root of 49. Now, you're looking for a number that when you multiply by itself gives you 49. In this case, we know that that number is 7. So we're going to rewrite it as s equals plus or minus 7. 7 times 7 gives you 49, which works. And negative 7 times negative 7 also gives you 49. So in this case, that's why we have a positive and negative. Now, remember that the example is talking about length, and length cannot be negative. So we are only going to keep the positive answer, which is 7. And we know that the length of the side is 7 inches. Now, cube roots. A cube root of a number is any number that can multiply by itself 3 times to get your original number. On page 14, you have the following example. You have a cube that has the height of A, the length of A, and the width of A. And it's telling you that the volume, because it's a 3-dimensional figure, is 125. So we're going to set it up similar to what we did in the previous example. You know that the volume is when you multiply every single side together. So you have A times A times A, which can also be written as A to the third power. And that will give you 125. Similar, we are going to write, in this case, the cube root, not the square root, but the cube root. So you write it with a degree of 3. And now this cancels out, and you have A equals the cube root of 125. And since you memorize these cubes, you also know that A will be equal to the cube root of 5 to the third power. Your exponent and your root cancels out, and now you have A equals 5.